All right, welcome back to Talk Tensors. Today we're diving deep into a paper that's all about how to get AI to not just see the world, but really make smart decisions in it. You know, like how to get robots to actually do things, build stuff, solve problems in real time.
Yeah, it's like we've made such progress with these vision language models, VLMs, right? They're getting so good at understanding pictures and text.
Right.
But when it comes to actually using that understanding to like take action, plan things out in a visual scene, that's a whole other ballgame.
It is. And this paper really goes right to the heart of a major hurdle there. So let's get to it. What's the main takeaway here?
So the paper is called GTR. Guided Thought Reinforcement Prevents Thought Collapse in RL-based VLM Agent Training. And the big problem they're tackling is something called thought collapse.
Thought collapse. Okay, what, like the AI is having a mental breakdown?
Well, sort of. You see, when you train these VLMs with reinforcement learning, it's like, giving a dog a treat when it does a trick. The AI gets a reward when it does the task right.
Okay, yeah, I get that.
But for really complex tasks, the AI needs to reason through a bunch of steps to figure out what to do. And thought collapse is when that internal reasoning process just goes off the rails. The AI's thoughts, they get super repetitive, they're often just plain wrong, and they don't seem to change even if the picture or the instructions are different.
So it's like the AI is seeing a totally different situation, but it's stuck in the same old broken way of thinking.
Exactly. Like, the paper uses this great example of the 24 points card game.
Right.
They show how, as the AI trains, it can get to a point where it just keeps coming up with the same wrong mathematical formula, leading to the wrong answer, even when the cards are completely different each time. It's stuck in this bad logic loop.
Yeah, that's a problem. Like, if the AI can't even adapt its thinking to what it's seeing, it's never going to be able to handle real-world situations. Our robot's going to keep making the same mistake over and over.
You got it. And the authors of the paper, they really stress that this is a huge issue for tasks that have a ton of steps, tons of different possible situations, and that require like deep reasoning. Things like playing strategy games or navigating a complex 3D environment like the ALF World benchmark they used in their research.
So just to clarify, the AI is basically flailing, coming up with these nonsensical thoughts that lead to wrong actions. And the reinforcement learning signal, like the reward it gets at the end, it's just not enough to fix that broken reasoning happening along the way.
That is the crux of it. Reinforcement learning, it's all about the final outcome. It doesn't give the AI the detailed feedback it needs at each step to figure out how to reason correctly.
Gotcha.
And get this, the paper even shows that this thought collapse, it doesn't go away just because you use a bigger model or train it longer. Like they tried it with Elava 13B, a massive model, and trained it for ages, but the problem persisted. Just scaling things up doesn't cut it if the underlying reasoning is messed up.
Fascinating. Okay, so we've got a good handle on the problem. Now for the solution. What did these researchers come up with to fight this thought collapse?
Enter guided thought reinforcement, or GTR. It's this cool framework where they basically hold the AI's hand, so to speak, and guide its thought process during the whole reinforcement learning training.
So instead of just letting the AI figure things out from the end result, they're actively shaping its thinking as it goes.
You got it. And here's the kicker. They do all this without needing mountains of human-labeled data for each and every step of the reasoning. Plus, they don't even need to train a separate, super complex model to judge the quality of the AI's thoughts.
Hold on. How do they automate this thought correction? That sounds seriously advanced.
Well, they bring in another VLM. They call it the corrector model. Like, imagine a more experienced AI, a tutor. This corrector, which is built using an existing VLM, it checks and refines the thoughts that the learning AI comes up with at each step of the training. So the AI is like, okay, I think this is the way to go. And the corrector's like, nope, that's not quite right. Try thinking about it this way.
So the AI offers a thought, the corrector critiques it, and then what? How does that feedback actually get used?
Okay, so GTR uses this feedback in two main ways. First, it uses a technique called supervised fine-tuning, SFT. It's like directly teaching the learning AI to come up with thoughts that are more like the corrected ones the tutor gave it.
Right. So that's the guided thought part of GTR.
Exactly. And then secondly, they also use this thing called proximal policy optimization, or PPO, which is, it's a pretty fancy way of making those reward signals from the environment actually work for complex AI so it learns to take the right actions. So it's a two-pronged approach. Learning to reason better and learning to achieve the task effectively.
Interesting. It's like they're teaching the AI not just what to think, but how to think.
Exactly. And to top it all off, they've got these clever tricks to make sure the data used for this thought correction is top-notch.
Like what?
Okay, so they reward the AI for sticking to the right output format, penalize it if it gets repetitive, and they even let the corrector model use tools.
Tools like what?
Like for the 24 points game, they give it a code interpreter to actually check if a mathematical formula is correct. Genius, right?
Smart.
And then, because the AI's behavior can change during training, which can mess up the corrections over time, they use this thing called dataset aggregation, or Dagger. Basically, it's like the tutor AI keeps showing the student good examples, even when the student starts making mistakes, making sure the AI doesn't stray too far from the right path.
Okay, that all makes sense, though. I got to admit, we're getting pretty deep in the weeds here. But the main idea of an AI guiding another AI's thinking during training is really cool. Now, the big question, did it actually work?
Oh, it worked. On that 24 points task, GTR blew the competition out of the water. We're talking success rates 3 to 5 times higher than other top methods, including some really powerful models like Quenville 2.5, Gemini, and even better than their own corrector model when it was just using tools. And the overall rewards the AI got during training, way higher.
Wow, those are some impressive results. And they didn't just try it on one card game, did they?
Nope. They also tested GTR on a few other card games in the gym cards environment. Numberline, Easy Points, Blackjack, the whole shebang. On those, which were a bit simpler, GTR still did really well, sometimes even better than a model that was 10 times bigger, Quen2VL. So it looks like GTR has some serious potential beyond just that one game.
Makes sense. And what about that ALF world environment? That's a lot more complex, more like the real world.
Yeah, well, on ALF World, GTR just crushed the basic reinforcement learning approach, which, as we expected, showed signs of thought collapse. Performance flattened out, even dropped during training. But GTR, it kept getting better, even when they took away the text descriptions of the environment that are usually used in ALF World benchmarks. This forced the AI to rely more on visual reasoning, and GTR totally nailed it.
So it sounds like this guided thought approach is making a big difference across the board for a variety of complex tasks.
Yeah.
And they did some digging to understand why it works so well.
Yeah, they did these things called ablation studies, which are basically like, what happens if we remove this part or that part? And they learned a lot. For one, that process guidance needs to be there the whole time. If they try to ease up on it later in training, boom, thought collapse came back. They also found that the corrector model needs to be really good at its job and have the right knowledge for the task. Like when they took away the corrector's tools for the 24 points game, performance tanked.
Yeah, the tutor needs to know what they're talking about.
Exactly. And then, of course, as we talked about before, Dagger was super important to make sure the AI's changing behavior didn't mess things up. And get this, they found that guiding just the thoughts was better than trying to guide the whole thought action sequence. Probably because the environment itself and the corrector already put some limits on the actions, so trying to force specific actions might confuse the AI and mess with its learning.
So little guidance goes a long way, but too much can be counterproductive.
That seems to be the case.
Okay, so let's zoom out a bit now. How does this research fit into the bigger picture of AI and machine learning?
Well, this work is part of a bigger trend where we're starting to use LLMs and VLMs not just to understand things and generate stuff, but as agents that can make decisions and do things in their environments.
Yeah, like actually act in the world.
Exactly. And early attempts at this, they often relied on these clever prompting techniques, kind of tricking the models into doing what we wanted. Then reinforcement learning came along, which was a game changer for fine-tuning these models for specific tasks by rewarding them for the right outcomes. But as we've been discussing, when you get into complex visual environments, just rewarding the final outcome isn't enough. You need to make sure the AI develops a good reasoning process to get there.
Right, because in tasks with just text, the reasoning is kind of baked into the language itself. But when you add visuals and actions, the AI's thinking becomes way harder to decipher and influence.
You nailed it. And people have tried other ways to provide this kind of process guidance, like training separate models to judge the quality of the AI's reasoning, or using VLMs themselves as judges. But these methods often need tons of human-labeled data, or the feedback they give isn't specific enough. GTR offers a way to automate this guidance and make it more scalable.
Makes sense. So what are the real-world implications of being able to train these VLM agents that can reason and act better in visual environments? thanks to GTR and approaches like it.
Oh, the potential is huge. Think about robots that can handle complex tasks in warehouses or even our homes, or autonomous vehicles and drones that can navigate all sorts of crazy environments, and even AI assistants that can really understand what we're seeing and help us in much more sophisticated ways.
And the fact that GTR doesn't need mountains of human-labeled data makes it much more practical, right?
Absolutely. It could open up all sorts of possibilities for developing these advanced intelligent agents.
Awesome. Well, before we wrap up, let's do our novel notions segment, where we take the research from this paper and brainstorm some fun, maybe a little crazy ideas for future research. What do you think?
Oh, I love this part. So this idea of guiding the AI's thought process, it really opens up some possibilities. One thing I'm thinking about, and the paper actually mentions this as future work, is extending GTR to promote multi-step reasoning. Not just thinking about the next immediate action, but planning further ahead.
Oh, interesting. So instead of just what do I do next, it's what's the best sequence of actions to achieve my goal?
Exactly. Imagine an AI trying to follow a recipe. Instead of just thinking about the next step, like chop the onions, what if it had a little internal dialogue guided by the corrector, where it considered different ways to prep the onions and how that might affect the later steps?
Like a mini strategy session in the AI's head.
Exactly. This could be inspired by techniques like tree of thoughts or reflection that have been used with text-based LLMs, but now adapted for visual environments and reinforcement learning.
Right. So the AI might think, should I dice or slice these onions? If I slice them, it'll be easier to caramelize them later.
Exactly. And the corrector could nudge it toward the best choice. This could be super useful for robots doing complex tasks or virtual agents that need to plan ahead.
Awesome. So moving from reactive decision-making to more proactive strategic behavior. I like it. What else you got?
Another thought is, what if the corrector model itself could adapt based on how well the AI is learning?
An adaptive tutor.
Yeah. So at first, the corrector might focus on the basics, like, can you even recognize the objects? Are you formatting your actions correctly?
Right.
But as the AI gets better, the corrector could start focusing on higher level reasoning, strategy, even creativity and efficiency.
Like a personalized curriculum, evolving along with the student.
Precisely. This could help prevent the AI from getting stuck in bad habits early on and encourage it to become a more sophisticated thinker. It's kind of like curriculum learning and reinforcement learning, where the tasks get progressively harder as the AI learns.
I like it. So the AI tutor is not just guiding, but also growing along with the student. That's a really cool concept.
Yeah, I think it has a lot of potential. Ultimately, it's all about pushing the boundaries of how we can make these AI agents truly intelligent decision makers in complex visual environments.
Well said. Well, this has been a fascinating deep dive into guided thought reinforcement. It's clear that this GTR framework is a big step forward in addressing thought collapse and helping VLMs reach their full potential for complex visual tasks.
Absolutely. And for anyone who wants to dig deeper into the details, we'll include a link to the paper in the show notes.
Awesome. Well, that wraps up another episode of Talk Tensors. We'll be back next time with more exciting research from the world of machine learning.
And remember, our Novel Notions segment is all about exploring fun, speculative research ideas, so don't take it all too seriously.
See you next time.